All right. Well, welcome everyone. Thanks for bearing with us here as we worked out a quick technical bug. Apologies for starting a little bit late, but I can assure you I'll watch the clock and make sure that we get out of here on time. For sessions like these, I like to start in an uncomfortable space for us engineers, often with a little bit of poetry that speak to the type of event that we're looking at today. So this piece here, It Couldn't Be Done by Edgar Guest. Somebody said that it couldn't be done, but he with a chuckle replied that maybe it couldn't, but he would be one who wouldn't say so till he tried. So he buckled right in with a trace of a grin on his face if he worried he hit it. He started to sing as he tackled the thing that couldn't be done, and he did it. Somebody scoffed, "Oh, you'll never do that. At least no one ever has done it." But he took off his coat and he took off his hat, and the first thing we'd know, he'd begun it. With the lift of his chin and a bit of a grin, without any doubting or quit it, he started to sing as he tackled the thing that couldn't be done, and he did it. And so, of course, we ask, especially us engineers, so what? Why start with something like that? And I think really in terms of why we're here today, what Jerry is going to speak to, what our two panelists are going to speak to, is just that the story of the poem. I think I was probably among the group that when we first met with Jerry, they were looking for some guidance and feedback. I saw all of the challenges and barriers that were ahead of them. And that's not unique to their technology. That's unique to almost every technology that I come across in my day job. And so, I just wanted to at least ground on that somewhat fundamental truth that there's all these barriers out there, but it's really through coming together, sharing our thoughts on the barriers and also coming together as an ecosystem where we can help each other overcome those barriers and ultimately thrive. And so that brings me around to CRIN. Just a quick, brief introduction to CRIN for those that haven't yet had a great opportunity to get to know the organization who's hosting today. Really, CRIN has a straightforward vision that Canada is the global leader in clean hydrocarbons from source to end use. And the part that really stands out to me in my role as a theme lead is when it comes down to the value proposition at the bottom and how we try to develop all of the events and initiatives that we put on. CRIN wants to be at the place where they're helping you get done what you do in your day job. And in particular, what we try to do through events like this is to create collisions that otherwise wouldn't have happened. And it's through those relationships and breaking down silos that we really end up being able to overcome all of those challenges and barriers that I talked about. And so what are we going to do today? The way that we've structured this, we're going to hear from Jerry about their scale-up journey, about how they've navigated from an idea through customer adoption, through the scale-up process, and where they're at today. So we'll learn a little bit about the technology, but I hope what really stands out is the lessons that they've learned as part of the journey. But we're also going to take a brief opportunity to create some collisions in the room here towards the end of the session. I was going to hope to get you talking a little bit with each other. There'll be a bit of a breakout, which I'll unpack after the presentation. And through sharing those lessons, we'll not only hear from Jerry, but we'll also be able to underscore and outline what exactly resonates from the presentation today so that we make sure that it stands out for everybody in the room. But quite frankly, there's going to be a lot of other lessons that you have learned in your journeys that are worth sharing and unpacking at a high level here as well. And so in terms of the agenda, appreciating we're starting a little bit late. I won't be long here before I hand things off to Jean and Brian. I mentioned the breakouts, and I'll watch the clock and just make sure that at about 10 to 1 that we start the report out and closing comment section. So I realized at this point I haven't introduced myself. For those that I haven't yet met, my name is Stephen Arseniak. In my day job, I'm the Director of Net Zero Planning and Strategic Initiatives for the Pathways Alliance. And in my volunteer capacity, I'm the theme lead for this novel hydrocarbon extraction theme. So under this novel hydrocarbon extraction theme, we get into the subsurface extraction and production parts of the business, one of 7 CRIN themes. On when we get into the breakout session, we've got Sally, who's going to help monitor that. So wanted to give her a quick shout out and always appreciate Sally's help. And then we've got our 2 presenters who, without further ado, I'll introduce. So to begin, we've got Gene Wasselchuk, who is the interim chief executive officer at GERI, a company that specializes in innovative enhanced oil recovery technology. He joined GERI in 2023 as the company was transitioning from R&D and field trials to commercialization of its game-changing EOR technology, which we'll hear more about today. Gene's vision, expertise, and leadership skills are instrumental in guiding GERI through this critical phase and ensuring its success in the competitive and evolving energy market. Gene is passionate about creating a positive impact on the environment and society through better and more sustainable practices in oil recovery, and is also committed to fostering a culture of collaboration and inclusion within GERI and with its stakeholders. Prior to joining GERI, Gene held various senior executive positions in the oil and gas sector, including multiple roles as VP, President, and CEO at several midstream and service companies. He also founded and led Creator Energy Innovations, a company that developed integrated and balanced power solutions using renewable and conventional energy sources. And Gene's joined today with Brian, who has a Bachelor of Science in Chemical Engineering from Queen's University. For the last 45 years, Brian's been continually employed in the energy industry across the spectrum of large majors, intermediates, and junior oil companies, and held positions at managerial and senior executive levels. In the last decade, Brian has focused on new thermal technology innovations, design, prototyping, and field testing. As Chief Technology Officer at GERI, he's been central to the development of direct contact steam generation, designing and building systems that reduce thermal project GHGs that led to more efficient reservoir recovery in both thermal and non-thermal oil fields. And so without further ado, we'll begin our presentation. Thank you.
Thank you, Stephen, and thank you everyone for being here. As per the introduction, I started in 2023 as the CEO or the interim CEO with GERI. And after I joined them, I realized, again, it's a very dynamic organization. It has a heck of a story to tell. And I thought it'd be definitely worthwhile for us to participate in this with the offer of CRIN to do so. And with me, the guy who's going to tell the entire story, because he was here from the start to when I started, is, again, Brian Kay. He's our Chief Technical Officer. But before I get into that, I just wanted to touch briefly on what GERI is. We're a Canadian energy transition technology company. That's the official designation we have right now. And we provide enhanced heavy oil recovery solution to simultaneously recover reserves that are oftentimes difficult to recover using conventional steam technology, and to reduce greenhouse gas emissions in that process. We achieve that using what is depicted here in this diagram, and it's something called a direct contact steam generation technology. And what it does is it takes water, natural gas, air, combines it in that little red chamber there, the co-injector, that's our secret sauce, and it comes out with a single stream of steam and combustion exhaust gases, and that then is injected into a heavy oil reservoir. So not only are we providing a thermal component of enhanced oil recovery as a mechanism, but we also provide the pressure enhancement associated with the gases that are injected. And we also provide the CO2 that goes in, and that creates a situation where you also get a change in the solubility associated with the oil itself. Initial pilots have shown that our production has increased significantly over the baseline, and that up to 70% of the CO2 that's injected continues to remain downhole. We've got some newer pilots that we're on right now that we're actually using a third party to confirm that 70% is something that is bankable when it comes to the rigor that's required to analyze just how much does stay in the oil or stays in the ground and how much continues to stay in the ground over time. The direct contact steam generation technology also allows producers to extend the life of existing resources, defers end of life remediation costs, reduces the need for continuous exploratory drilling in new oil projects. Basically lets you squeeze out the last amount of oil that you possibly can in a situation as far as recoverable goes over and above what we see right now. This diagram basically shows us that not only are we highly portable, but we have a very, very small standard size that we can definitely fit easily onto a well lease. You don't need any new drilling. You limit land disturbance because of that. No costly infrastructure investments. Everything that you see here is what you need in order to be able to deploy our technology. It's applicable to both vertical and horizontal well types. And it can also be deployed in thermal and non-thermal cased wells. And for the non-thermal cased wells, we developed another technology that's called a annular cooling loop. And what it allows you to do is inject steam into a well and protect a non-thermally completed well. No thermal cement, no thermal casing, and basically carry out a steaming operation safely and without compromising the integrity of the wellbore or the casing. So we're not going to get away without an uncomfortable quote for an engineer again here. How did GERI come up with this idea? So let's step back here and let's use this as our lead into this. About a pile of rock ceases to be a rock pile when somebody contemplates it with the idea of a cathedral in mind. The rock pile that GERI saw was this vast, untapped reserve base that is probably recognized in the world right now as the largest known reserve base in the world, and that's the marginal or the significant amount of oil that continues to be in the ground after only a 5 or 10% marginal recovery rate has been applied against it. So when you look at that, the chance and the opportunity of being able to get more of that oil out was definitely a strategic vision that came to mind. The ability to take advantage of significant untapped potential that turned into a lucrative business opportunity that, not only did it unlock the dormant potential of those now or potentially to be soon abandoned oil fields, but it also turned into a lucrative opportunity because what was once seen as a potential liability is now something that you can actually attach a value to. And the last part of it was to do that in terms of being able to use innovation, transform that lucrative business opportunity into that potential. So before I hand this over to Brian, who's really got the big story to tell you here and has got all of the scars to show that this was sometimes an easy journey and sometimes not, I just want to emphasize that GERI never lost sight of those end goals and focus as it related to what we've laid out here, and that the drive towards technical prowess, operational efficiency, and cost effectiveness was one of the key things that both motivated us and kept us going. So Brian, if you can take it here. There you go. Thank you, Gene. You bet.
Morning. Okay, the story of GERI. Gene, thank you for that good introduction. It actually sets me up so I don't have to say as much at the very beginning. We sat down in 2012 with a fellow by the name of Jean Friedman, who was actually a World War II hero, as well as an entrepreneurial investor and involved in the movie industry. In fact, that's how he first entered into Alberta, got into the oil and gas business. The predecessor company to GERI was called Fortune Energy. And in 2012, Mr. Friedman said, I think I've had enough of conventional oil and gas development. I want a bigger challenge to solve. And he said, Brian, do we have any problems we can solve? And I like this heavy oil idea. Well, it didn't take too long for Jean and I to come up with a list of things and problems in the industry. And I'll just go through a few of these quickly. Stable oil prices is absolutely essential because of the expensive, complex, long regulatory, environmental hassles, problems to actually get a project launched and underway. In addition, ESG concerns, land use, high water use, a big factor these days. And we focused initially in the Lloydminster area, where Fortune Energy had some properties. And a lot of the wells were not thermally completed, neither cased thermally nor cemented thermally. So how do you get that oil out of the ground since only 10% is recovered or less? And the other problem is for a large thermal project, SAGD, you need a large field and you need thick reserves. A lot of Lloydminster was very small pools. So we came up with the idea of needing 50 million barrels of oil in place to be economically attractive. So Mr. Friedman said, is there some way we can access this? Is there some way to get this oil out and do something that, we can be on the cover of Time magazine? So we took that as our challenge in, like I said, 2012. The core value proposition for the company was that steam and flue gas, or combustion exhaust gases, can increase oil recovery. We had several papers done, SPE and worldwide, showing that combustion flue gases combined with steam would have a number of beneficial impacts on the reservoir, and you wouldn't need these large heavy oil deposits or bitumen deposits. So lower steam oil ratio, lower carbon footprint, better ESG performance, GHG performance, less land use. And a big thing with our technology, because a direct contact steam generator is very small, is you can make it portable and remove it easily and quickly. And again, the idea, as Gene mentioned earlier, safer steam, either if you have a downhole tool or if you have a surface tool, it's you're protecting the casing. So the original challenge for GERI was design a downhole steam generator. That's where we started, the way many other companies have started. Make it 100% energy efficient and make it so it only needs minor refurbishment. Designed and fabricated it so you can easily put it in the hole and recover it quickly. Build it at low cost, test it at low cost, and then just commercialize it in an optimized time frame. So not exactly trivial challenges, but that was the challenge that we were launched on in 2013. The reality hit us very quickly in 2014. Downhole direct contact steam generators are very difficult to ignite, and they're not reliable. They're also not very efficient. They require real-time monitoring to be efficient, and it's very difficult to get the proper transducers downhole, either temperature sensors, TCs, or pressure transducers. Expensive to manufacture, we found that out very quickly. And limited runtime. Our first prototype tool lasted 22 minutes before it melted. So that wasn't exactly where we were supposed to be heading. So limited runtime life was a big thing we had to work on. Installation removal from the wellbore, time consuming, expensive. Eventually, GERI ended up with over 70 different designs. If we'd remained downhole, we would have been in and out of the hole 70 times, which is prohibitively expensive. So not a short path to success, and we had very fortunately understanding investors. The GERI solution, very quickly, eliminate downhole. In other words, just give up. Don't go downhole. Put everything in a pressure vessel on surface. And if you think about it, the actual direct contact steam generator, if it's in a pressure vessel, it doesn't know if it's downhole or it's on surface. So we could do all our testing, get everything worked out, go through our 70 different iterations, and we could develop the perfect tool without going in and out of the hole. We decided also to minimize combustion fluid dynamic modeling. This is very expensive and very time consuming, and we thought there's a better way to do that. And the way we did it was we found and promoted, hired personnel with, I call it 3D visualization and intuitive mindsets. These people are fairly rare. They're not necessarily engineers. They're certainly not necessarily PhD engineers. They're certainly not necessarily combustion fluid dynamics engineers, but these are intuitive people that can look at a situation, look at physics, and with 3D visualization, come up with very creative solutions. So we came up and found 2 people like that. And that was a big part of developing our success. A few other things I'll just touch on quickly. Very quickly, our the general manager came up with the idea of using cheap carbon steel components. In other words, you don't have to use the austenitic steels or nitrile type compounds. You can, if the tool is going to fail in 20 minutes, why not test it with basically carbon steel components? If it lasts longer than that and you're having success, then you start using expensive steels. Test ideas and concepts away from the well. Very, very important. You don't want to go on a well site and be bound and limited by constraints on the lease if you can do testing in a lab. Or in our case, we found a parking lot just on the edge of Lloydminster where we could set up a tank where we put all the effluent gases and steam in and test it that way. So rather than jumping right to a well site, we did a lot of testing that way. Rapid prototyping. We all have heard of the fail fast, a very prudent way of doing things. In other words, get it out of the way, see if it's going to work. If it doesn't work, then it fails, and then where do you go from there? So we adopted what we called a fail right approach. In other words, when you're doing the failure testing or testing your concept, always have plan A, plan B, and perhaps even a plan C in place so that you can always migrate quickly away from your fail fast with different ideas. And this really has a benefit for people that are working on this. Some people that believe you're going to fail fast and the idea or prototype won't work. So they're already thinking of different ideas. And this allows you to move quickly through a rapid prototyping process. A big learning for us, this is natural human intuition concept. Wow, we could try this and we could try this idea and try this idea. Let's try those all together. You don't want to do that because then you don't really know why things have failed. So even though it takes more time, as soon as you have one distinct concept, test it alone and by itself. And that was a lesson we learned quickly, but we always had to keep reminding ourselves of that. Document, pictures, and then connect everything together in a story. Very important. 3 weeks later, after a design has failed, you want to be able to go back because memories aren't perfect and not argue among team members of what happened. You want to actually have the documentation there. And the old adage, a picture's worth 1,000 words is most correct. But you got to connect the dots. And that might literally be putting drawings down and putting arrows and time frames and dates on those. So very, very important. That's where we found engineering discipline to be extremely important because the engineers have the discipline to do that and follow all these creative ideas with 3D visualizing and intuitive mindsets. So quite a balance between people. The last point is perhaps should be the first point, having a clear pathway to success that meets the overall objectives. So I say we've already pivoted from a downhole tool to a surface tool. We had all the other objectives, trying to be commercial, trying to have a tool that lasts a long time, trying to deploy safely and easily. These objectives had to be always kept in mind, and you had to remind yourself of these dailies, otherwise you ended up going down rabbit holes. The slide here, I kind of ran out of room on one slide, so I created this separate slide with different things were very important in the GERI development process. Number one was actually from one of my old bosses. And when I came in and I said I didn't have the right tools to do the job, he said, I'm going to eliminate that problem for you forever. So I carried that philosophy through into GERI. So people never had the excuse they didn't have the right people, the right tools, the right equipment, the right field test environment to prevent success. Another key one here, again, with a small company like GERI, we were able to do this. You have to have a very short distance between the design engineers, the field operators, the mechanics, and everybody. And I mean by short, I mean a short physical distance. Everyone has to be in the same room, the same testing lab, the same site. You can't be working some of this in Calgary or Edmonton and then translating it to experience in Lloydminster. And also a hierarchical distance. Everyone is not the same, but you can't have people coming in and saying, I'm the boss, I want to do it this way. You have to go back, like on the other slide there, to these creative 3D mindset people and follow their lead. And that's sometimes difficult to do if you're in a hierarchical position. very important, we discovered this the hard way, is know when to quit for the day. At some point, your mind's not working anymore. You're going to come up with solutions that are wrong, that you'll think tomorrow morning, there would have been a better way to do this. So rather than work till 10 o'clock at night, we learned when to stop. And that had also safety implications as well, because you start not thinking clearly and doing stupid things. Budgets, I'll mention that for our investors. We always need to realize that it's going to take more time and effort to do things than what it actually does. And I think you've probably heard this before, when you ask the team, how complete are you? And they say, well, I think we're about 95% complete. You're really only about 50% complete, because there's all sorts of problems come up after the fact, especially when you consider going from an R&D prototype, say TRL 6 or TRL 7 to TRL 9. There's a lot of effort goes in there. So having investors familiar with R&D environments was a great godsend to GERI. And with Mr. Friedman's help, we had the right investors involved. And I've mentioned this briefly before, but the careful balance between the supervisory decision-making and the all-team consensus. And I call it a weighted democracy. Everyone has their input, everyone has their say, but some people you listen to more than others. And safety, safety, safety. Mentioned that before, but we had our general manager in the field, Wes Topko, always take a look at things and put everything through basically a mini HAZOP process. And what we found was being in the field wasn't the problem. It was the things you wanted to do quickly in the lab or in the warehouse. It was those quick tests you had to be careful about. So again, diligence on the safety, safety, safety. Again, show the slide before, but everything I've talked about here is in that red box, the direct contact steam generator co-injector. Everything else here is a science all by itself, the compressors for the air and the fuel, and of course the water. Everything has to be carefully balanced in there. So in addition to all this, we had almost $750,000 spent on a PLC system, because direct contact steam generators need 100 millisecond reaction time. So the whole process we talked about here takes us from 2013, where I started the talk, through today, where we're commercial ready and ready to develop. A long path, long arduous process, not easy to do. And like I said, over 70 iterations of the tool before we got things right. I thought I'd throw this slide in. It's actually from a previous presentation we made a few years ago. Why do startups fail? GERI's almost guilty of all of these, but we saw the light at the right time. So I throw this out just to the audience without really going through it. These are key things. They apply to any business and very important to keep in mind. And I'll just close on this slide before passing it over to Jean. I call the slide balance, balance. And cartoon-wise here, never give up. You got to have that mindset when it's always the darkest just before dawn approach. So the frog preventing himself from being swallowed by the stork. Great analogy. But you have to balance that off, that sometimes the dragon wins. And when the dragon wins, well, you're not the frog anymore. You're some pieces of armor laying on the ground. So balancing those two off, realizing when to fall back, go back 3 or 4 steps, engage your creative mindsets and redo things. It's a hard lesson, but it sometimes has to be done. Thank you. I'll pass it on back to Jean.
Thanks, Brian. Every time you tell that story, I learn something new. And in this case, I'm just going to follow up with the same thing that Brian just said, that again, all that success, we know it's hard work. We know it's prep. We know it's a lot of failure, but it's also that balance that we're talking about. And, as you look forward, as you move into potentially doing the same thing as far as developing new technology, you got to remember that with the failure, don't worry about it. You only have to get it right once. So with that, thanks for attending. If there's any questions, we're going to be able to take them here afterwards. We also got a breakout session that Stephen's going to be talking about briefly. And we hope you guys got something out of this that we're able to pass on. Thank you.
Don't run away too far here. We did want to slip in a quick question and answer period before we go into this breakout phase here, because I think as I was sitting there reflecting, especially on the comments that you were making there, Brian, there's a really subtle fine line between knowledge and wisdom. And so what I see up on the slide is a lot of really great summary points, great knowledge that everybody can take away. But I think what we have the opportunity for here is to drill in just a little bit further and try to understand, those hard-fought lessons that you've learned over time. And so I've got the mic handy here. If there's any questions that come up in the room just about your journey, either about that or the technology, and then online, if there's any questions, if we could get you to type those into the chat box, and I'll check in with Sally here to make sure that we get any of those questions addressed. But just to give folks a brief reprieve from being on the spot, I was maybe going to ask a quick question to get us started here. And that's that, I really, I guess, appreciate the prototype, fail smart approach that you were taking. And I saw a lot of really good advice about budgets and making sure you've got enough contingency and the right investors, et cetera. But I was just wondering if you could maybe expand on your story a little bit in terms of, how you ended up with the customer or didn't end up with the customer that allowed you to do those tests in the real world. Maybe how you bridge that, because at least from my experience, most of these oil companies out there are pretty risk averse, and it's really difficult to take a technology like yours, which I would, broadly frame as a third-party technology, and to put it on their wells and allow you to fail. And so you must have had some really good insights around how you grappled with that. So yeah, I'd love to hear a little bit more of that part of the story. Oh yeah, or you can come back up and.
I'm sure a lot of people will think that's a leading question, but actually it isn't. But I have something I would really like to talk about regarding exactly what Stephen just mentioned. Mike Crabtree at Saskatchewan Research Council met with us very early in this process in 2013, and he knew the problems exactly that Stephen brought up. Is how are we going to take this technology, develop it, and then convince some oil company how to do it? So Mike Crabtree, working with the Saskatchewan government and SRC itself, developed what they call the Well Test Center program, which allowed competitive technologies to come in and work a very lucrative royalty reimbursement scheme where the companies would be encouraged to test new technologies. So that's how GERI got started, and it led to our first two significant field tests with two largest operators in the Lloydminster area. So my hats are off to Mike and the group at SRC. And one of the creative mindsets that I talked about earlier was Farrell Baird at SRC. Again, very instrumental in working with Mike to make this all happen. So my advice to anyone with a startup company is try to find encouragement in government sources or research organizations like SRC, which can really move you far ahead. And without SRC involved and the advice they gave us as well, not going to the field too fast and words of wisdom like that were very, very beneficial to us.
All right. Any questions from the audience today? Not yet, anyways. Maybe I'll ask just one other quick one. I'll do it from this mic so that we don't get the feedback. But yeah, I think one of the other quick critiques that I had, when I first learned about GERI, was just about the narrow lens from which I was looking at the suitable reservoir through versus the full landscape of potential suitable reservoirs out there. And so I guess just for the sake of the audience, like one of the specific concerns I had was around the combustion products and, putting all of those in a reservoir that wasn't that wouldn't benefit from all the combustion products in the reservoir. And, quite clearly you were able to find other markets beyond the one that we were talking about, where adding that CO2 to the reservoir was actually a benefit, right? And so you must have gone through some sort of customer engagement process. I feel like I was probably not the only person you talked to as part of that journey. And so I just really was hoping that you could maybe share a little bit more knowledge or guidance with us in terms of the process that you went through to gather that customer feedback, for lack of a better term, and make sure that it was properly incorporated into your plans.
Yes, there's many actual ways to answer that question. I'll give a few examples or snapshots. One is no matter how much reservoir modeling you do, the proof is in the field. We did buy a well just south of Lloydminster for our own purposes, and we demonstrated with very careful measurements with third-party validation that about 70% of the, I'll call them the non-condensable gases, the NCGs, CO2, nitrogen, stayed in the ground. And this was not only good for getting rid of CO2, but the nitrogen repressurized the reservoir. And about half of the benefit on the oil production from our steam oil ratio was actually due to that repressurization of the reservoir. So the heat, repressurization, and CO2 enhancement, plus, of course, permanently putting it away in the reservoir, at least 70% of it, was very beneficial. When you have concrete field results, you can directly go then to a customer and say, here's our results, open book. And having that third-party validation from the engineering and actually on-site witnessing of what we're doing was very, very important in promoting the GERI story. After that, it's let's give it a try, let's go somewhere else. So GERI's gradually over the years tried different types of reservoirs, different environments. And again, the oil companies tend to lead you there themselves, going, I want to try it in a field where I cannot move in and make a SAGD operation profitable, but maybe GERI can go in with portable equipment and easy deployment and just simply try it out and see that it works. So again, seeing is believing, and very careful documentation and third-party validation results will convince a customer, but it's not, even then, it's not that easy.
Can I ask a question about a little bit about telling us more about your market penetration, like some of the oil and gas companies you're working with and how that's going?
And thanks for that question. Since I've come on, we've definitely amped that up. That was the point in time where we were 100% commercial in terms of being able to be deployed. And we have taken a fairly aggressive stance in terms of who we've approached and where we've approached companies. So not only are we domestically being able to take advantage of opportunities, but we are going international because there is a significant heavy oil opportunity worldwide. And in many cases, the component of that is related to wells that are not thermally completed. So the angular cooling loop that we have was probably one of the biggest inroads that's getting us into the international market, specifically because many of the wells that were originally drilled never ever had any intention of doing thermal operations on them. So market penetration right now is definitely evolving. It's something that is picking up pace as we move through the steps here in order to be able to get more exposure. And then again, for us, if there's one thing I can pass on to anyone who's looking at creating a technology or being able to get something to market is never stop talking about that product, because regardless of how simple you think it is in terms of the solution, it never translates that way, because we have often been mistaken as a company that has a downhole steam generator. So as much as we say that we started off with the downhole steam generation, but we evolved into a direct contact steam generation on surface, it's still somehow, after an hour meeting with nothing but PhDs who are highly skilled in terms of what it is that they're doing, they still think that we're a downhole generation company. So all of those things kind of all translate into the fact that you need to make sure that you constantly message and that the message has consistency associated with the most basic and fundamental parts of your actual technology. I know I didn't answer your question, but hopefully I got enough in there. Thanks.
All right, we've got one question here.
Thank you so much. I'm always amazed with Jerry's stories and journey. I just have a question regarding your lab validation. I want to know what kind of validation did you perform and at what conditions, how long it took you to get a certain good package to offer it to, let's say, for funding or investment, that kind of purposes.
By lab validation, I'm assuming you mean the actual prototyping process in the lab and also, of course, the theoretical modeling. Both are separate, both are important. We utilized a lot of actual core work in developing our technology to see what impact combustion exhaust gases and steam would have in a controlled lab setting. And again, Saskatchewan Research Council was very useful in providing large-scale lab testing of that nature. That gave us some theories of where we needed to go and what the tool design needed to look like. But our actual lab testing was done at Petrospec in Edmonton and our facilities in Lloydminster. And these were quick, simple tests. As I said earlier, there was over 70 different iterations of this tool. Some were half-hour tests, and we scrapped the design. But in essence, we kept all that information away from the general public and really the effort started after we brought Gene on board and became commercial ready. All the trials and tribulations mentioned and saw the arrow diagram there earlier. It took 10 years to get where we were to where we are. And we're now successful, but to share that with investors is one thing, to share it with oil and gas companies, something completely different. So we wanted to be a success. We wanted to have a workable product. And that's what happened when we engaged with the two major oil companies in the Lloydminster area. We actually had a working technology. We knew it was going to work, and we convinced them fairly quickly that the results would be there.
All right. Well, it's about 1:45, which means that I'm hoping that we could maybe spend about 5 minutes or so just doing this quick breakout that I talked about. And I guess the two reasons I feel a little bit obligated to give you a sales pitch for why this is important, because it's a little uncomfortable. Two reasons. One is that as wise as these two gentlemen are, they don't know everything, with due respect. And I feel like with the wisdom that we have in the room here, you've all got these fantastic perspectives that are probably worth sharing. And so I've tried to highlight 3 questions there that kind of get at those types of questions. Like, you know, from the presentation today, is there some lesson that really stood out to you? Where has your experience led you to different conclusions? And where has your experience yielded other important lessons? So trying to get at, you know, some good lessons here. But I think the second bit in my sales pitch here is really that you know, within CRIN's vision, we can't keep Canada as the global leader in clean hydrocarbon production from source to end use in silos. And so what I hope through this short, you know, little 5-minute exercise here is that if you see each other in the +15 or at a future event, that it'll be just that much easier to say hi, and we can really start to break down some of those silos that actually get in the way of innovation and progress in our industry. And so with that, maybe let's just take, like I say, 5 minutes. The chairs are movable, so it is really easy to get that started. And then I'll watch the clock and bring us back here with enough time to get out by 1 o'clock. So over to you. All right. Time flies when you're having fun, but I want to make sure that we get out on time here as well. So I know I kind of circled around the room and had seen a few really engaging conversations happening here. So I wonder if I just might take this other mic. I'll start at the far end, and we'll see if we can get a couple good insights out of this. So.
Yeah, we were just sharing thoughts about the whole aspect of coming up with the idea. By the time you get it tested in the field and getting operators on board, that whole risk aversion, we're trying to grapple with that whole concept and the amount of dollars, time, and effort it took to the point in time for an operator to actually test it in the field? What can be changed in the ecosystem to be able to accelerate that? Because I mean, your investors must have had a lot of patience. There's a lot of dollars that are spent down in that valley before a customer ever has the confidence to try it on their field. And I don't think the customers are set up for success either, because there's not a lot of incentive for them to try new stuff. But if you screw something up, they're, you know, 1,000 attaboys versus one, so it's just that issue. How do you bridge that gap is kind of what we were talking about. Does anybody else have any other comments? Okay.
So I run a small oil and gas company. We're developing new technology, seeing a lot of the same things that came up on your slide deck. So thank you very much for presenting. I appreciate it. It's nice to hear that we're not the only ones that struggle. But the main takeaway for me was matching your investors' attitude with your own, or your concepts. Felt like that was really important. I know that a lot of companies struggle with that, right? People are expecting results really quickly, and when you're in the R&D space, it's not quick. It's you have a lot of things that need to get done. I mean, you mentioned regulatory. That's just one thing that slows some things down. And then, of course, just all the testing and everything that you talked about. The other thing that I thought was very insightful was the two individuals that you mentioned who think differently than engineers. I thought that was really important. And so having those people on the team is something that's required, I think, when you're in a startup. I think without those types of people, you're stuck right in that sort of defined pathway, and there's no sort of creative thinking, and like you said, it could be from anywhere. And so we've also found those people as well too, from different disciplines. So I thought we hadn't put a label to it. You guys put a label to it. Do you know what I mean? Like those 3D visual thinkers. But so thank you very much.
Sally, maybe I'll just check in. Was there any takeaways from online? Okay. Last call for takeaways from today. Okay. Well, I guess with that, maybe I'll start in with some closing comments here then. So again, just a quick reminder about CRIN. So CRIN is free to join. So nobody that showed up here today had to pay for the event, which was great. Actually, one thing I forgot in the introduction, with my day job at Pathways, I was really happy to sponsor lunch for everybody today. And so that's what we try to do at CRIN, right? We try to bring people together, break down silos, remove those barriers. And so we hope to do that not only through events like this, but also what we do more broadly in the ecosystem. So bringing together different organizations to collaborate in different ways, so on and so forth. And so, check out the CRIN website, quick social pledge, that you'll help others as much as they help you. And you'll get the newsletters, get more information about events like this, and then, contribute as part of the community. So within our novel hydrocarbon extraction theme, we've got a couple more events that are coming up here very quickly. One that I'm particularly excited for is on March 20th. It's been absolutely fantastic pulling that group of people together and collaborating with folks even in this room here to get that organized, which is an absolute pleasure. So the registration's open. It's on the events page within the website. And that event in particular, what we're going to do is a panel discussion, a little bit different than this. There's no forced breakout, but we'll have a midstreamer, producer, and a technology developer together on the stage to talk about CO2 EOR in Canada and what some of the challenges and barriers are, compare us to other jurisdictions, and try to find some credible path forward to help that out. So one that I'm particularly interested in. And then the April 24th event, we haven't got that quite up on the website yet, but should be up about a month ahead of time here. That one really comes down to the hidden product manager that you need to bring some of these digital technologies forward, and some of the good leading and best practices for bringing those digital technologies forward as well. So as always, if you've got ideas, like these events just don't magically appear, let us know if there's a particular need in the ecosystem that you see. Reach out on LinkedIn to myself, to others on our theme team, and we'll continue to bring the community together to solve those challenges. And so with that, I guess I'll leave you with where we started, a little bit of the poetry. Lift up your chin and give a bit of a grin without any doubting or quit it, and start to sing as you tackle the thing that can't be done and do it. Thank you, everybody.